Hello, class. Welcome back. We are covering 6.6 here today, which deals with synthetic division. So last time we looked at long division with polynomials. So we're looking at another type of division that you can use instead of long division in certain cases. Okay, so let's just kind of recall long division. And let's take a look at this. So if we had something like this polynomial 20 minus 11x plus 4x cubed minus 5x squared divided by x minus 2. So when we did long division, we would have x minus 2 out here. And we would have to put this other polynomial, this one over here, in descending order. Okay, so we would start with the 4x cubed, then the minus 5x squared, and then the minus 11x, and the plus 20. And we don't have anything missing, so we don't have to use 0 for the placeholder. Okay, and then we would try to figure out, okay, x times what is 4x cubed, right? So it's 4x squared. And then we multiply, so we get 4x cubed minus 8x squared. And then we subtract this. These guys cancel. That becomes positive 8. Minus 5 is 3. And then we bring down the minus 11x. And then we repeat the process. So x times 3x will give us 3x squared. And 3x times negative 2 is negative 6x. And we subtract this. They cancel out. That becomes a positive 6 and a negative 11. So that's negative 5x. Bring down the plus 20. And we get negative 5 here. We get negative 5x plus 10. And we subtract this. These guys cancel. That becomes negative 10 plus 20 is 10. So that is our remainder. So we would say plus 10 over x minus 2. Okay, so that's the long division way. So we're going to take a look at this exact same problem using synthetic division. Okay? All right, so now we're doing synthetic division. And what happens is this is kind of a quicker process, I think, than this long division. But you only use it when you're dividing by certain polynomials. Okay, so you can't use this completely in place of long division. You can use this only when dividing by like x plus 2 or x minus 2. Okay, so x plus or minus a constant. So if you're dividing by something like x squared plus 4, then that's not going to work. So if you're dividing by x squared plus 4, that's not going to work. If you're dividing by 3x minus 1, that's not going to work. Okay? It has to be 1x, not 3x. It has to be 1x, and then plus or minus some number. Okay? So that's when you can use this synthetic division. Okay, so over here, if you notice this problem, we're dividing by 1x minus 2. So we can use synthetic division on this problem. So that's what we're going to do here. Okay, so let's take a look at that same example. So it's the same one as above. Okay, and we're going to do 20 minus 11x plus 4x cubed minus 5x squared divided by x minus 2. Okay, and so again, here we're going to arrange it so that this polynomial is in order, descending order, and we use 0 for placeholders, just like in long division. Okay, so let's go ahead and rearrange. So here we're going to go ahead and write it as 4x cubed minus 5x squared minus 11x plus 20 divided by x minus 2. Okay, so what we're going to be doing here is we're going to be setting it up differently. Okay, so what happens is I'm going to go ahead and draw a line here. Okay, so on one side, this left side will represent the x minus 2 portion, and then this side will represent the this polynomial over here. Okay, so this is how you set it up. If you have x minus 2, then over here will be the solution to that, which will be x equals 2. Okay, so here, let me go ahead and write that down here. So this would be the solution to the divisor, the thing you're dividing by, divisor, and that was x minus 2. Okay, so if you have x minus 2, then and you solve this, x minus 2 equals 0, right? And then you add 2 to both sides, so x equals 2. Okay, so that's what we put on the left side, x equals 2. And then over here, what you're going to do here is you're going to write down just the coefficients of the polynomial. You don't have to write the full polynomial, just the coefficients. And so that's why it's important to make sure that they are all in order. So 4, -5. And if you are using a 0 placeholder, you would write 0. Okay. -11 and +20. Okay. So these here are just the coefficients of the other polynomial. Okay. And just like with long division, we want to make sure that it is in descending order. And you also want to use 0 for placeholders. Okay, so use 0 placeholder for missing terms. Okay, so there we go. All right, so so that's the setup. Okay, so now let's take a look at the process. Okay, so again, over here you have the solution to x minus 2. And over here, you just have the coefficients, and make sure you include their signs. Okay, so that's a -5, and that's a -11. Okay, so that's the setup. So now we are going to take a look at the process. All right, so I'm going to go ahead and write that setup down here again. There's too much in the way for me to do the work. Okay, so we have 4, -5, -11, and 20. Okay, and then so what you're going to do now is you're going to leave like a blank space here. Okay, leave a blank space because we're going to be writing the numbers down over here underneath them. Okay, so leave a blank space. Okay, and what we're going to do is we always start, so the process is always the same. You always start with bringing down this coefficient here. Okay, whatever it is. All right, and then whatever you have written down here, you're going to go ahead and multiply it with this outside number. So 4 times 2, and you write the answer underneath the next coefficient. Okay, so that's how we start. Always bring down this first coefficient, multiply it by the outside number, and put the answer in the next column. Okay, and then what we do here is we go ahead and combine these. So unlike long division, we were always subtracting. Okay, so here we're not subtracting. We're just going to go ahead and add these together, -5 and +8. Okay, so here we get 3. Okay, and then I repeat the process. So I take this 3, multiply it by this outside number, and I put the answer underneath the next column. Okay, so we get 6. And then I add these again, -11 plus 6. I get -5. And then I take that -5 and multiply it by this outside number. I get -10. And then I add these together and I get 10. Okay. So what do all these numbers mean? Okay. So first of all, these here are the coefficients of this polynomial over here, right? Okay. So 4, -5, -11, 20. 4, -5, -11, and 20. Okay. So we know where these come from. Okay. But what I want you to notice is that these are the coefficients of a degree 3 polynomial. Do you see that? These are the coefficients of a degree 3 polynomial. Okay, so that makes a big difference. Okay, so these numbers are the coefficients of that degree 3 polynomial. Okay, so let's go ahead and write that down. Coefficients of a degree 3 polynomial. Okay. Okay, so because we know this is a degree 3, then what happens is down here, these are going to be the coefficients of a polynomial that's 1 degree less. So if this here is degree 3, then this here will be degree 2. Okay, so these are going to be the coefficients, and it's just these 3 here. Okay, I'll talk about this last number in a bit. Okay, so these 3 numbers here represent the coefficients. Let's spell coefficient right. Coefficients of a polynomial one degree less. So here the degree would be a 2. Okay, so because this one's degree 3, so this one here is degree 2. Okay. All right, now if you end up with a number here other than 0, then this number right here is actually your remainder. Okay, so that's what that 10 is. Okay, so when you write your answer, okay, so this is going to be a degree 2. So this means this is going to be 4x squared plus 3x, and then it just goes in order. So 4x squared, so here's your answer. So it's going to be 4x squared because it's degree 2, and then it goes in order. So positive 3x, and then minus 5, and then that's your remainder. So we're going to say plus 10 over x minus 2. Okay, and if we take a look, that's exactly the same answer that we get up here when we did the long division. 4x squared plus 3x minus 5 plus remainder 10, right, over x minus 2. Okay, so we get that exact same answer. Okay, so it might seem like it's a lot of work, but it's not. It's because I have to add all of these little side notes here to the work that we're doing here. Okay, but let's go ahead and take a look at another problem. And we'll do a few so that you can see, yeah, these are pretty easy. Okay, all right, so let's take a look at this one. All right, so suppose that I'm doing 6x squared minus 29x minus 5 divided by x minus 5. Okay, all right, so x minus 5, so x equals 5 is out here. And then in here, we'll have 6, negative 29, and negative 5. Okay? All right, leave some space. Bring down the 6. 6 times 5 is 30. Write the answer in the next column. Add. Multiply. 1 times 5 is 5. Add. We get 0. Okay? So here, this is a degree 2. So this must be a degree 3. I mean, degree 1. 1 less. It's always 1 less. Okay? So then our answer is going to be 6x plus 1, and then 0 remainder. Okay, so that's how we do that one. I'll do another one. All right, let's take a look at this one here. Suppose I'm doing x cubed plus x squared minus 1 divided by, using the fraction bar now to represent the division, x minus 3. Okay, so when I set this up, x equals 3 here, and we're going to have 1. We're missing the x, so we're going to put a 0 placeholder and negative 1. Okay, so see how we're missing the x right here? X cubed, x squared, x to the first is missing, so we use a placeholder. Okay. All right, leave some space, bring down this first coefficient, 1. Multiply 1 times 3 is 3. Add them. Multiply 4 times 3 is 12. Add them. Multiply 12 times 3 is 36. Add them. And we get that. Okay. And this was a degree 3. So this one will be a degree 2. Okay. So our answer is 1x squared plus 4x plus 12. And then that's our remainder. So plus 35 over x minus 3. Okay. Do you see how that's working? Okay, I'll do another one. And then I'll have you try one. Okay, suppose I have 5a squared plus 6a cubed plus 2 minus 4a divided by 8 plus 2. All right, so setting it up, a equals a negative 2. And then over here, this is out of order. All right, so 6 will go first, and then positive 5, and then negative 4, and then 2. Okay, make sure it's in descending order. All right, let's bring down 6. Multiply 6 times negative 2 is negative 12. Add these, 5 and negative 12 is negative 7. Multiply, negative 7 times negative 2 is 14. Add these, we get 10. 10 times negative 2 is negative 20. And we get negative 18 for our remainder. Okay, so this is a degree 3. So this will be degree 2. So this will be 6x squared minus 7x plus 10. And then this is our remainder. So minus 18 over, oops, it's actually a's. I changed the variable. Okay, so a plus 2. Okay. All right. Let's have you guys try this one. Five x squared minus 4x minus 33 divided by x minus 3. Okay, so go ahead and hit the pause button, give it a try, and then come right back. All right, so setting this up, x equals 3. This is already in order. Bring this down. 5. 5 times 3 is 15. 15 and negative 4 is 11. 11 times 3 is 33. And we get 0 remainder. Okay, so this is degree 1. This is degree 2. And so therefore this one will be degree 1. So that's going to be 5x plus 11. Okay. All right. And go ahead and try this one as well, just to make sure. Let's see. I'm going to have you guys try this one. X cubed plus 3x minus 62 over x minus 4. Okay. So go ahead and hit the pause button. Give it that one a try and then come right back. All right, so setting this up, x equals 4. And we have 1. We're missing x squared. So hopefully you put a 0 placeholder there. And then 3, and then negative 62. All right, let's bring this down. Hold on, the gardeners are outside. Hold on, I gotta close my door. Okay. So bring down the 1. 1 times 4 is 4. Add these together. And then 4 times 4 is 16. Add these together. Now I need a calculator. Okay, so 4 times 19, 76. Okay. And then when you add these together, you should end up with 14. Okay. All right, so this was a degree 3. So this one will be a degree 2. So 1x squared plus 4x plus 19 plus 14 over x minus 4. Okay. Okay. I'm going to break this up into 2 sections. So that's how you do the long division. So that's how you do long division using synthetic division. I'm going to go ahead and do remainder theorem and the factor theorem in the next video. Okay. So if you have any questions, make sure you text me or email me.